Hi, I'm Kathleen, and today I'll be talking about Physics 2212, Lab 1, about charged tapes. The purpose of this lab is to approximate how much excess charge is on one piece of charged clear tape, and we can do that using Coulomb's law and gravity. Coulomb's law says that like charges repel and opposites attract, and the formula is that the force of electricity is K, which is a constant, times charge 1 times charge 2 over the distance between the charges squared. And then the force of gravity is negative G times the mass. And the main results of the experiment were that the tape had a deficiency of electrons, and that one piece of tape had an excess charge of about 9.3 times 10 to the negative ninth coulombs. So before going into the main experiment, I played around with the tape a little bit. I put a piece of charged tape near my hand and found that the tape was attracted to my hand, meaning that the tape was indeed charged. And I did the same thing with a book, and again, the tape was attracted to the book. And then I put two pieces of charged tape near each other, and they were repulsed by each other, meaning that the two pieces of tape had the same charge. But we still don't know what that charge is. So then I used a pin, a plastic pin that I had run through my hair, giving it a negative charge, and I put the tape near that. And the tape was attracted to the negatively charged pin, meaning that the tape had a positive charge. The experimental setup was to have two pieces of tape, 20 centimeters each, that were both charged. So tape A would be the source charge, and tape B would be feeling the charge from A. And putting each end of tape B onto something that was the same height, and then putting A under B, and then bringing A closer and closer until B started to float. And then noting that distance between A and B at which B started to float. So the weight of the tape was about 0.0002 kilograms, and I started with A and B being about 0.05 meters apart. We also in this experiment have to assume that there's no drag force, that each U-tape has the same net charge, and that each tape has all of its charge at a single point at the center of the tape. So this is my code for this experiment. I just typed in all of my constants and then created source A and observation point B to be the spheres representing each piece of tape. And then I calculated the force of gravity, and because nothing is moving at the point where tape B is floating, we can say that the electric force is equal to the magnitude of the force of gravity. And then we can rearrange Coulomb's law to find what Q is, Q being the charge on each piece of tape. And using that, we can figure out the deficiency or excess of electrons that tape B has. And then using that and the length of an atom, we can figure out the ratio of deficient electrons to atoms. Here's the result when you run my code. So because both pieces of tape are positively charged, I have them both as red dots, and then the force of gravity is green, and then the force of electricity is yellow. And then you can see there the numerical results for my code. One possible source of error is the fact that the model doesn't account for drag, which would have been present in the real experiment. Also, during the experiment, some charge was probably dissipating. And also, it was pretty difficult to measure the exact distance between the two pieces of tape when tape B began to float. Finally, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? And really, there wouldn't be too much difference because the tapes would still repel each other because, well, now they would both be negative instead of positive. However, the tape would repel the negatively charged pin instead of being attracted to it as it was before. And then why is it so important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? And you want to hold the tapes as little as possible because the more the charged tape touches things, the more charge will dissipate. And for experimental results, you want a strong electric force so that you can see the effect easily. So it's best to avoid neutralizing the charge by touching things.